Hey everybody, thanks for joining us for our Multipurpose with MultiJet Printing webinar. I'm Jason Jarash. I'm the president of Noda3D, and I'll be kicking off the first portion of this webinar, and then we're going to kind of dive into some other things. This is the first of a series of webinars that we at Noda3D are going to try to do, kind of covering all the various technologies and maybe diving into some deeper applications as we go on through this. So. But yeah, so I'll kick it off here. Let me share my screen. Cool. So some of you may be existing customers, or maybe you guys have worked with us in the past on machine evaluation, and you have some experience on how we work. But some of you may have no experience or have no idea who Noda3D is. So. At Noda3D, we're really focused on creating the best customer experience, and I know a lot of companies say things like that, but you know, it's really part of who we are. And I always say what you do is who you are, and I believe our customers will definitely back us up on that as well. So at Noda3D. We're a company that does nothing but 3D printing and 3D printing software. 100% of our focus and expertise is in additive manufacturing. Our team has over 45 years of experience in the 3D printing industry, and we really focus on a lot of complex applications. So naturally, over time, we've developed a specific process that has been proven to work time and time again. Of course, initially, we like to discuss your process and your workflow, identify the issues and opportunities where 3D printing could be a solution for you. Then we like to dive deeper to get the creative juices flowing, and then we'll put our ideas to the test, and we want to prove out our results. And so once we can prove out that our solution is a good fit or will work, then we'll make an official recommendation. And then, you know, at that point, if you decide to implement the technology or implement our solution, then you know, that's the absolute most critical piece. Is what comes next. That's the post-implementation support. So we don't just drop off the machine and you never hear from us again. We're very, very proactive in our post-sale support versus reactive, which is what a lot of other companies do. So that's really where we try to separate ourselves from the others. So for today, we're going to do a quick high-level overview on MJP, who uses it and why. We're not going to get too far into the weeds on the technology itself. If you have more interest in that, definitely feel free to reach out to us, and we'd love to dive into that a little bit further. And then once I kind of run us through what MJP is and who uses it, then we're going to have Joe Corbell walk us through the 3D Sprint software that comes with and is used to operate all of our 3D printers. After that, we'll wrap up with an interview with Ellie O'Brien. She's a current MJP user, and she's going to talk about her experience with the equipment and how it's helped her. So quick note, the 3D printing world loves acronyms. So we are going to refer to MultiJet Printing as MJP. So you'll hear us using MJP a lot. That's what it is. So at MultiJet Printing is this specific technology. So why do companies like to use MJP? Well, I mean, it's mainly because of the wide range of benefits that it provides. So there's many reasons why companies would choose to use MJP. And if you were to ask our customers, the most common that we hear back are the ones that you see on the screen. So, you know, extremely high resolution and detail, crisp corners and edges. A really big one is, you know, the no maintenance print heads, easy material changeovers that don't require excessive purges and wasted material, and then not to mention the wide range of materials available. So, you know, based on having such a broad range of capabilities, MJP is usually a pretty good fit for a broad range of industries. And here to help me talk through some of the various industries that we've helped over the years is Tom Rohrbeck with our company. He's a longtime veteran with the additive manufacturing industry. He actually started his career with 3D Systems back in 1986. And over the years, we've worked with pretty much any industry that you can think of, but here's a few key ones that we're going to dive into today. So, Tom, you with us?
Sure, sure.
All right, cool.
Yeah, one of our more popular market segments that we see is medical. The medical industry really demands high precision parts. Based on the high precision of the MJP systems, that's why they are bringing in the MJP.
Yeah, exactly. So I think, healthcare is probably one of the largest industries that we see MJP, seeing it as a fit. So from medical device companies that are printing, device prototypes to dental labs printing orthodontic models and hospitals printing pre-surgical planning models, and then universities printing medical educational models. And so that's the one that's an application we're going to talk about a little bit more today. But another big thing is MJP offers a really wide range, several biocompatible and Class 6 certified materials. So kind of with those, medical grade materials paired with, high accuracy makes it a great fit for the medical industry.
We have a number of customers that fall within the electrical market. And what we find with our electrical customers is that they really require high resolution, high detail on their parts.
Yep, exactly. And so, obviously having that type of resolution and detail makes MJP another great fit for that. But also we have some new materials that have come out, including a new high temp material. So what that's actually allowed is some of our customers to wave solder, printed components, and that's at 280 degrees C. So that's also become a huge factor into companies using MJP for electronic prototypes.
Architecture is a very interesting market segment. We have a number of customers that use other processes in the past, but based on the easy post-processing with wax on the MJP, many of our customers that are in the architectural market are using that system.
Yep. And, another thing to add with architecture. So if you see the parts on the left side of the screen, so what this picture is, you can't really tell very well, but we actually had a customer that had purchased a 2500, and she was printing a really large model of kind of like a skyscraper, and she had to print all these little conference tables that had to go into the model. And so obviously the resolution was able to, make it so we could print these, fine little legs, but also post-processing. We had to print 105 of these. And, so post-processing that could be a total nightmare, but we actually were able to print all 105 in one build. We were able to nest it up. And since we used the support wax, which we'll dive into a little bit further in a couple minutes, but we were able to batch build, and then we were able to take basically this entire block of parts, and we were able to post-process them all at once. So it made it, very easy, made it very simple, and there was no damage to the parts, which is something very common with other technologies. So that's been a huge factor for architecture, but we see that in a lot of other industries as well, being able to print, big batches and post-process in big batches.
Yeah, for recreational equipment, the sporting goods industry, I find a lot of those customers are really looking for options and materials, and really tough materials. Some of the printers they looked at and evaluated didn't offer those capabilities, and that's why they came with the 2500.
Yep. Yeah, exactly. So in fact, the part in this photo is one of our larger customers, and we printed this part on a ProJet 2500 Plus out of our armor material, which is a very tough material. And they were comparing this part against a 3D printed ABS part. And during my sales call with their team, the customer actually stood on a chair or on the table and repeatedly dropped our MJP part and the ABS part on the ground, trying to see if one would break. And they both held up, but our part never broke, even though my heart was racing. I kept a smile on the whole time. But so they ended up choosing MJP after that because they were able to keep the high strength without having to sacrifice the surface finish and detail and accuracy. So that was a huge win for them.
Consumer products is another really big market for the MJP product. And these customers typically do lots of different geometries at all times. So throughput, speed, and versatility, where it's different material options and whatnot, become a big part of their requirements.
Yep, exactly. And since most customers have a wide range of products and projects, one or two materials isn't going to fit every project. So especially in consumer products, these companies need a machine that can be flexible to their needs and offer different materials that can meet their ever-changing project demands. And we work with faucet and valve companies that do high pressure flow testing, and soft drink machine manufacturers that do high pressure water hammer tests for extended periods of time, and they need those materials to hold up. But then on the other spectrum, we have companies who are designing and creating toys, and they don't need that strength, but they really need that extremely high detail for the visual models. And then you have our packaging companies that are doing, different packaging designs, and they need living hinges and, materials that are going to replicate polypropylene with a surface finish that they would expect from a blow mold or an injection mold. And, so all of these different companies have different needs, but they're all using the same technology to be able to achieve that. So, those are some of the industries we just wanted to touch on today. And a lot of these things that we talked about for certain industries carry over to other industries, as in the benefits that one industry sees, a lot of them can see it in another industry. So, all right, well, moving along. So what exactly is MJP? So how does it work? Some of you may have seen this before in the past, but MJP works similar to an inkjet printer that you probably have sitting at your office or your desk. We load in cartridges of material, a liquid material that gets fed to a print head. The print head shuffles back and forth over the build tray. It jets out a model material and it jets out a support material. We use a wax support material that allows for easy melt-away post-processing and batch post-processing that I was mentioning. But we also use what's called phase change chemistry in our materials. So we slightly heat up our material in the machine, and then when we jet it, it's partially cooling and solidifying on the way down. So we can really, really control our droplets much better than the competition. That's how we can offer such high resolution and really, really crisp detail. Since we kind of touched on this a little bit earlier, but since it's unlikely that all of your projects have the same needs and requirements, it's really important to find a machine that's going to offer material flexibility and a wide range of options. So we have our engineering grade materials for projects that require functional testing of high accuracy parts. Then we offer high temp materials for obviously high temp applications or even rapid tooling. Then we have our standard rigid and elastomeric materials for concept and aesthetic prototypes. And we actually even have a version of the 2500 that prints in a true foundry wax for investment casting. On our 5600, which is the large version of our MJP technology, that machine actually allows you to blend multiple materials at once. So that gives you the ability to create custom blends and specific durometers, so you can tailor the parts to your project needs. And one thing I kind of wanted to add in here is one thing that 3D Systems does really, really well is they put a lot of time and money and effort into developing materials and capabilities for the existing machines, right? So our flagship machine, the ProJet MJP 2500 Plus, that machine's been out for about 5 years, and we've added 7 materials, just even in the past 3 years to that machine. And if you own that technology, we just let you run it, right? So we just tell you, hey, here's an update, and now you get to run this material. So we don't charge you to, for a material package, or we don't just say, hey, I know you bought that machine 6 months ago, but if you want to run this material, you got to buy the new one. So it should give customers a lot of confidence in making a purchase in this type of technology, that it's not going to become obsolete anytime soon. So this is the MJP line of equipment. Between any of these machines, we're really going to have something that's going to meet your size and material requirements. And we'd obviously love to talk with you further about your needs to see if MJP would be a good fit for you. So please follow up with us after the webinar, and we'd like to dive into that a little bit further. Now, I'm going to pass it off to Joe Corbell to run through our 3D Sprint software. 3D Sprint is the software that comes with all of the 3D machines, 3D Systems machines, and we use it across all of our technologies. So 3D Sprint is super easy to use and offers a ton of user control over their files, and which is great. So there's a lot of different capabilities within 3D Sprint, but for today, Joe's just going to dive into a couple for you. So,
my name is Joe Corbell with Noda3D. I'm the applications engineer. I'll be going over today the split function in 3D Sprint. So to get started with that, we're just going to take a general geometry that we can create right in Sprint itself. Let's say we pull in a part that's a little bit too large for the build plate. Call it 12 by 10 by 5. So that'll generate this large cube that we can see is clearly outside of our build platform, but that's what we want. So the software will automatically kick it off to the side, just because it can't print a part that big. So like I said, we're going to go into the split function that's at the top right here in the toolbar. Go ahead and click on that, and it gives us the option to cut on a plane or cut on a line. Obviously, we're not too tall for the build platform, but we are too wide. So we'll take the Y and Z split. We don't really need a clearance for these parts. The clearance would be if we had some sort of bonding agent where it would need to fill in a gap. So since we're not going to be using that, or the super glue that we would use is thin enough, we're going to go ahead and keep the 0-inch tolerance clearance for that. So we'll click next. You can see that there's actually connector pins for this that are automatically generated. You can choose to turn those off, but for the sake of demonstration, we'll keep them on. It'll help kind of line everything up as if we were actually making this part. So we can dictate whether or not it's going to be a box connector or a cylinder connector. We can dictate whether or not it's going to be a sphere, so rounded off, or a chamfer. And the smaller these pins get, the chamfer will go away, but the sphere function will still work. So we can say, all right, we want to do 250 thousandths by 250 thousandths. That will give us our connectors there. We can choose to do the male only for the rounded off, kind of give the female connectors a kind of a bottom out. Can choose the tolerance. Again, this will only be if you're using a bonding agent that will require more space than you would actually need in the part itself. So we'll leave that at 5 thousandths as a good guess. That'll give us just enough wiggle room to line everything up correctly as we need to mate it. Instead of letting the software kind of dictate where all of the connectors will be, we can do a grid pattern. We can say we want 8 rows of 4. We can space these out differently. Can kind of turn the grid and everything like that. And you can line this up any which way you would want. You can do female to female connectors in case you had dowel pins or something that you wanted to connect in. So you don't need to use the connectors that come with the software. It's just automatically generated, so they make it nice and easy. So we'll go ahead and turn that. We'll say done. And it gave us our 2 halves. So what we want to do in this case is save off 1 half because we're only going to be printing one at a time. So we'll go File, Export. And we're exporting the box split number 2. You can export as STL, CTL, OBJ, WRL, PLY, and AMF files. STL is going to be the easiest to work with, so I'll just export that out. Save that. Click out of that. And then we can go ahead and delete this out. So from here, we'll just use our auto place feature, let the software kind of decide how to turn this so it'll fit on the build platform. And there we have it. So we would add this to our printer queue, and then we would load in the other part. So we'll delete this one out as if we added it to the queue. File, Import, and we'll take our box 6 split 2. We have the same connector pins, auto place again. And we would print this as well. So once this is finished, you would simply mate the parts together, super glue, or use a UV curing adhesive. Really any number of ways you want to bond it. It's pretty simple to do. But going from there, I'll generate another box. Say we have another part that's far too large. We'll say set. The other side of the split function is the line tool. So anywhere that you take a perspective view from your part, it's essentially going to slice it right down the center of that. So since we're not directly straight on, we can't turn our camera. It's going to slice it directly through this part. We can kind of choose whatever kind of style of teeth automatically we would want instead of having to draw these out by hand. So the dovetail, we could add more or less teeth. They'll get smaller or larger depending on how many more you take. You can kind of adjust the line from here as well. You change the back end of it, make them wider. You can also add a clearance for these parts. Again, since we're not going to be using any bonding agent, we don't really need a clearance. It might make it a little bit easier to mate together if we have a 1/1000th clearance there. So we'll go ahead and do that. Click Next, and it slices straight down the center of the part from where we had our viewpoint. So we'll say Done. Again, we'll highlight our part, export it as an STL. And we'll delete that portion. Now we can see if this will fit by hitting auto place. It's outlined in blue. Everything fits just perfectly. And we would add this to our queue. And again, we would delete that out. Reload the split that we deleted earlier. Auto place and auto rotate. And we would add this to the queue as well. So you can see down here, there is a little bit of a cutoff there, but if we're really careful and we take a different viewpoint, it's pretty easy to avoid that. So we would just add this to our queue. We would print both the parts, slide them together and lock them in place using the adhesive that we would need, and we would have our fully combined part. That covers the split function. If there's any other questions or concerns, you can always go to the 3D Sprint help. You can type in split, and it'll help kind of walk you through everything on this page. So that's it for me. I believe we're moving on to Ellie next. We'll take questions at the end.
For the last portion of our webinar today, I'd like to introduce Ellie O'Brien of Northwestern University Simulation Department. Ellie has been instrumental in the medical modeling activity at Northwestern for the last 8 years. And she was involved in the evaluation, justification, purchase, and implementation of 3D Systems MJP 2500 Plus. I'd like to thank Ellie for joining us today and sharing the challenges of her responsibilities at Northwestern and experiences with the 2500 Plus. So Ellie, could you tell us a little bit about you and your staff and what you do at Northwestern and how 3D printing has benefited that activity?
Sure. So I work in the simulation lab, specifically in the innovations portion. And what we do is support the medical education that happens at Northwestern University's Feinberg School of Medicine. And we really design simulation models for medical education and research. The innovations portion that I run is staffed solely by me. So we, or I and my summer interns, and I have a few part-time students who are undergraduates at the university. We work one-on-one with physicians to design medical models to fill the gaps in the education that they're teaching.
So this is primarily for medical applications related to education.
Yes.
Okay, great. So it sounds like medical modeling and simulation is the biggest part of the service you provide to professors and surgeons. How did the demanding requirements of those models influence your decision to bring in 2,500 plus?
Sure. So as you mentioned earlier, I've been with the lab for about 8 years. And when I first started, we weren't doing any 3D design or any 3D printing. Everything was just done by hand. And I really tried to push us towards 3D printing and 3D design because we wanted to make more anatomically accurate models. We wanted to be able to provide our students with the same experience, and 3D printing would allow us to do that. So the reason I ended up choosing the MJP 2500 Plus was mostly because of the multi-material function of it. I was previously using another printer that was a powder plaster based, which I really loved for mold making, but it didn't yield a lot of the parts that we could put directly in our models. So having the ability to print both in a hard and soft plastic right in the lab was really the biggest deciding factor. And another thing is my space is pretty small. My old printer was very large. So being able to decrease the footprint of the printer in my space, as well as like decrease all of the post-processing that I had to do from before. The post-processing with the MJP is so easy. And so just a few of the main factors that went into this purchase.
Oh, great. What about 3D systems in Noda? Did that come into the play in the decision on bringing in that machine?
Yeah, so the previous printer I had was an old Z-Core, which was acquired by 3D Systems. So I was used to working with 3D Systems already, and Noda was my partner for that, and they were already servicing the machine. So the transition to getting a new printer, it was just so easy and seamless to do it through 3D Systems and Noda. We were able to just swap my old one out for the new one.
Great.
Yeah, it was a breeze.
So how long have you had your machine now?
I've had the MJP since last July, so just under a year.
Oh, great, great. What materials do you typically use in that machine? Are you using the armor or some of the other materials?
So I haven't actually used the armor yet. I've, been using just like I'm going to end up using like the material name for it that I know I buy based on the consumable list. But both like the white and clear, I think it's like the W2R white and clear hard plastic.
Okay.
And then I've just started using I don't even know what you guys call it, but more of like the softer.
The material with the better yield strength.
Yes.
More flexible, yes. Okay,
Yes.
Okay. So over the last year that you've had the machine, I'm sure you've done numerous projects that were successful. Could you share a little information on some of those projects and how having the 2500 plus benefited the output?
Sure. So I spent the majority of the last year working on two main projects, both of which that were similar to each other, but I was working to design an ultrasoundable model that would train physicians how to access the femoral artery under ultrasound, place a catheter, and then be able to like snake the catheter up to the heart. So this is a very common thing that happens in the cath lab and has to be done under ultrasound. And so what I ended up doing was designing, I refer to it as a cassette, but it's essentially like a rectangular piece that has the femoral artery and the femoral vein that I designed in SolidWorks, 3D printed the molds for, first just 3D printed straight on the MJP to test for size and shape and just looking at if the anatomy was accurate. Once we determined that, ended up designing the inverse of it, 3D printing that inverse mold, and then casting silicone with some ultrasoundable things in it to get us the final part that we could put into our model. So I did. So
the silicones you use, are those a UV cast silicone, or are those like a two-part silicone that harden because of the two-part mix?
There are two. I use a two-part mix.
So I was wondering if you use like a clear material, if the UV would radiate through the mold and you could curate inside with a UV silicone. Because I know there's a lot of medical grade silicones that are UV curable.
Yeah, I actually haven't used any UV cured ones thus far. Mine have all been two-part mixes, but lots of, you know, it's so funny. I went to school for biomedical engineering. I'm not a material scientist, and I don't even know if material scientists would just have this innate sense of these sorts of materials. So every new project, in addition to the design and the print of the mold or the part itself, is a lot of trial and error and figuring out what materials best simulate whatever the tissue in the body is that we're trying to simulate. So
is the majority of the data you get all through CAD, or do you do some direct scan data to produce parts?
We do direct scan data too. And actually one of the other projects that I spent some of this last year doing was working with a neurologist, and they were training their residents how to place a drain in the lumbar spine. And all the models on the market were looking at lumbar. So your lumbar spine curves. There's a curve in it down to your tailbone, and all of the models on the market, everything is straight. And so being able to access the space between your vertebrae when it's straight is a lot easier than when it's curved and that space is really small. So what we ended up doing for his project is actually taking a scan of someone with normal anatomy but has the curve in the lumbar spine, segmenting out the part that we want, editing it, 3D printing the spine itself, and then designing a mold around it that we could place the spine into and cast silicone around that spine to get a final part that has an anatomically accurate spine and makes placing the lumbar drain much more realistic to what they would see in a real human.
Wow, wow. Does the machine you have handle your capacity requirements now, or are you pretty much busy on the machine?
Right now, it's been handling it pretty well. I also have access to the rapid prototyping lab at Northwestern's engineering school, and they have an array of other printers. They also have an old Z-Core powder-based printer. They have an ObJet 250. They have a Stratasys Fortis. So it's pretty nice because depending on what I want my final material to be, I can just pick and choose which printer. And so between my stuff and their lab, I have enough. Yeah.
Hey, with the current issue with Corona, are you finding that you're getting your jobs done? Since you're working from home right now, are you going in to run the machine at all?
No, I am not allowed to be on campus.
Oh boy. So
I have not had the printer on since I think March 16th was the last day I was allowed to be on campus. So I shut it off before I left, and I've been designing things, and I'm just like waiting until I can get back on campus and it'll be up and running. Day
Sounds like you're gonna be pretty busy when you get back.
Yes, I will be. Yeah.
Okay, well, to sum it up, what would you say the main benefits to Northwestern that you've realized as a result of the MJP 2500 Plus?
You know, for me, the biggest thing is just having something like right in my space that I can just pop on the printer and have it done hours later to test shape and size of something. But I love the fact that you can swap materials and have the flexibility of a hard or soft material, using the armor, using something that's, you know, less or more brittle. I absolutely love that. And And honestly, it's so easy to use. Like I think, is it 3D Sprint? The computer program that goes along with it is just like seamless to use. Getting things on and off the printer are easy. Like I said before, the post-processing is like a dream compared to what I was doing before.
Yeah.
So it's been great. Yeah.
Well, that's great. Great. Well, thanks for sharing your experiences with us today. If you have any questions for Ellie, please type them in and we'll get you responses as quick as possible. And again, thanks again for joining us today.
Thanks for having me.
Thanks, Ellie.
Awesome. Well, thanks Ellie, and to everyone else involved. And that's pretty much it for us today. I'm going to go through. We do have a handful of questions that I'll answer, and if you're thinking of anything more, definitely feel free to type it in or reach out to us. But so one of the questions we have here is, you mentioned that the material changeover process is simple. Can you please explain that? So the way our material changeover process is, basically we have 2 cartridges of material that feed the print head, as I mentioned. And with our machine, what you do is you have 2 options, actually. You can remove those cartridges out of the machine, and then you can load in what we call MCO cleaner, so a material changeover cleaner. And basically what that does is it runs through the lines. It's very inexpensive, and it runs through the lines and it cleans out any resin that may be in the lines. But we also don't flood the print head and flood the lines like some of our competitors do. So you're wasting very, very minimal amounts of material, whereas some other technologies actually use model material to purge through the lines to flush them out. And so that's very expensive and there's a lot of waste. Or the second option is you can just not use any cleaner at all. And it's called the print through option. And basically you just pull out the old cartridges and load in the new ones. And then, maybe your first couple builds, the first couple parts you have might have a little mishmash on it. It might be a little discolored, but, that way you're not wasting anything, and it's very fast. So, that's kind of a user preference, but, either way, we make it very simple, and we make it very cost effective without a lot of waste. So, let's see. So another question we have here is, what other softwares do you use for medical models like Mimics? We at Noda3D, we don't use Mimics, so we offer a technology called Dicom2Print, and that is for segmenting. So it's very similar to Mimics. The only difference between Mimics and D2P is D2P has some automated tools. So if you're doing a lot of like bone, teeth, or vessels, we have automated features in there, so you don't have to go through and do it manually. It does it very fast. If you're doing more soft tissue things, then yes, then that's definitely going to be very similar to Mimics, and also we're much less expensive than Mimics. So, and then the last question we had was, you had mentioned that armor material, what makes it superior to other resins on the market? So that's a good question. So armor is, well, resin in general it has like a notion of being brittle, right? A lot of people think of like the old SLA machines, or some of like the MultiJet, where maybe the parts look nice, but they're very brittle, they're not functional. So the armor has really changed that. So it's a really, really tough material, as I mentioned. It held up and actually exceeded the expectations of a lot of our customers, especially when comparing it to FDM ABS parts, and it has really high yield strength. So that's the main difference between armor. So it's a clear material. It still gives you the really high resolution and high detail that all of our other jetted materials give you, but it also gives you the strength. So that's really the key there. And that looks like it's it. So if you have any other questions or anything else pops up, feel free to reach out to us. think that's it for us, and I appreciate everyone joining us today.